Alright, let's take a look at 2011 number 2, the pot of tea that's cooling. We are measuring it by a differentiable function on 0 to 10 where t is measured in minutes and h of t is measured in degrees Celsius. Values of h of t and selected time values are shown in the table above. Okay, use the data in the table to approximate the rate at which the temperature of the tea is changing at time equals 3.5. Show the computations that lead to your answer. Okay. Well, I think you guys kind of already know what I tend to ask here, and that really is, what is the highest level of math necessary to solve this problem? And it's Algebra 1, right? If I wanted to estimate t of 3.5, I'm going to squish 3.5 in between the 5 and the 2. So what I'm looking at is h of 5 minus h of 2 over 5 minus 2. And that is going to be 52 minus 60 over 3. And that's going to be, it looks like, negative 8/3. It doesn't say indicate units of measure, so I square that up and I move on. Next thing, we're going to go ahead and use correct units. We have to explain the meaning of h of t in the context of this problem, and then we're going to use a trapezoidal sum with 4 subintervals to estimate the value of this integral right here. So let me go ahead and set up the graph real quick. Okay, for part B, let's take a look at what part B represents. Well, the integral from 0 to 10 of h of t dt, well, what it does is it represents the total change in the temperature, right? Like how, you know, what was the temperature from 0 to 10, and these are the selected values. But if I was to throw this 1/10 on the outside, the 1/10 represents the average temperature, right? So that's all I have to really write, is that the 1/10 times that integral represents the average temperature, darn. In degrees Celsius on the time interval 0 to 10, where t is measured in minutes. So minus a little bit of a typo there. I think we're doing okay. Alright, let's set this graph up, and then we'll figure out, or at least estimate, those values. Give me a second. Okay, cool. So I've got my little graph drawn there. And I'm going to go ahead and use a trapezoidal sum with 4 subintervals. What do you know? 1 trapezoid, 2 trapezoid, 3 trapezoid, 4 trapezoid. Cool. So what I've got here is I'm going to go and add those up, and I'm going to, by adding them up, I'm going to estimate this value. Cool. So the area of a trapezoid is going to be 1/2 height base 1 plus base 2. So what I've got here is, it's going to go B continued. The first trapezoid is 1/2. Well, what's the height of the first one? Looks like the height is 2. Base 1 is going to be 66 plus 60 being the second height. Then I'm going to add that to the next rectangle. Well, it's going to be 1/2. Base is 3. First height is 60. Next height is 52. Plus 1/2 times 4. And then base 1 is going to be 52. Base 2 is going to be 44. And then 1/2, the last height is 1. And then base 1 is 44 plus the last base is 43. And at this point, you could actually stop the problem and just leave it there. You don't have to simplify anything that's of this nature of mathematics. But I'll go ahead and just do the answer real quick. And after all is said and done, you end up with 52.95. Alright, that's part B. Part C, it says evaluate the integral from 0 to 10 of h prime of t dt, and using correct units, explain the meaning of this expression in the context of this problem. Well, if h of t represents the degrees at that time, then the derivative of that is going to be the change of those degrees within that time, right? And if we integrated from 0 to 10 of h prime of t dt, well, what we'd get is we'd get the total. Since we're just explaining, I'll go ahead and switch to text. We would get the total change in temperature of the pot of tea on the time interval 0 to 10. So let's see what that actually is. Well, if I integrated from 0 to 10 of h prime, kind of like the particle problem, I'm going to use the fundamental theorem of calculus. I get h of 10 minus h of 0. Do I know those two values? I think we do. 43 minus 66? And that equals either 43 minus 66, or you can just punch in your calculator. Negative 23, which means the biscuits changed 23 degrees. I'll go ahead and punch that in. Oh, not the biscuit, sorry, I'm looking at part D. The tea, the tea's temperature changed negative 23 degrees in the first 10 minutes. Okay? Alright, let's clean this up a little bit and we'll go to part D. Alright, in the last part of this problem, they're saying that time equals 0, we've got these biscuits that are a temperature of 100 degrees Celsius when removed from the oven, which means right as soon as we pull them out when time equals 0, they're 100 degrees Celsius. So it says the temperature of the biscuits at the time is modeled by a differential function, and it's known that b prime of t, in other words, the change in temperature of those biscuits, is modeled by that negative 13.84 function. Using the models at time equals 10, how much cooler are the biscuits than the tea? Well, here's what I'm going to do. I'm going to go ahead and find out the temperature of the biscuits at time equals 10. And then I'm going to find out the temperature of the tea at time equals 10. Actually, I don't even need to figure that out. I think they gave that to me, right? It's 66. And when I said 66, I meant 43. So 43 degrees on the tea. I just got to find out the temperature of the biscuits. So how do I do that? Well, I'm going to go ahead and look at integrating, looks like from 0 to 10, of b prime of t dt. If I do that, again, fundamental theorem of calculus part 1, it's coming up again and again and again. What I get is I get b of 10 minus b of 0. Well, do I know what b of 0 is? I think I do. It's negative 100, or it's 100, but I'm going to be subtracting it. So I know that I'm solving for b of 10 by doing that. And how do I figure this out? Well, first thing I'm going to do is I'm going to punch this thing into the calculator. So what I've got is I've got the function right there. Everybody see it? And it's my new F1, so I'm going to go ahead and hit the calculator that's running away from somebody. And what I've got here is I'm going to go and go Shift plus, and I've got from 0 to 10 of F1 of x, dx. And that gets to be negative 65.8172. Negative 65.8172. So that is negative 65.8172. Again, I'm trying to solve for b of 10, so I'm going to add 100 to that value. So what do I get? Well, I get b of 10 being what? Well, b of 10, I'm going to take this answer, I'm going to add 100 to it, and I get 34.182 So 34 point, and I can't even remember that number, big number, 18275. 18275. Okay? So that's the biscuit's temperature at time 10, but I want to compare that to H of 10, the temperature of the T. Well, that's 43, right? Well, it looks like how much cooler are the biscuits than the T? Well, let's go ahead and just subtract those two. That means that I've got B of 10 minus H of 10. Okay, so I'm going to go and take that number. I'm going to subtract 43 from it. Oops. And I get negative 8.817. Negative 8.817. So what does that mean? It means that the biscuits are 8.817 degrees cooler than the T at time equals 10. Bam. And that's how you do it. All right? We'll see you in the next FRQ.